what we have now is the need to do some mechanisms. And these are carboxylic acid mechanisms. These give the same product, but with a very different mechanism. They're both esters from the same carboxylic acid. They're both methyl esters. This one is a diazomethane esterification. Diazomethane. You'll notice the section number there if you're trying to study these at home. Just in case one of these shows up on a test and it wasn't on the previous test, and you're surprised you didn't know it was coming. And guys, lecture activities are definitely game for every test, every single lecture activity, right? Okay, so we got methanol making an ester. Hey, alcohol, carboxylic acid, sulfuric acid catalyst. That's called the Fischer esterification. It's not even new. We looked at it way back in chapter 10. Go ahead, go look at chapter 10. It's in there with mechanism. We're doing it again here. The classic condensation reaction, isn't it? We could have put a DST in here to make it go a little better, get a better yield. Okay. This diazomethane mechanism, you're going to love it. How does a CH2 minus become a CH3? That's a CH2 minus. How are you going to make it into a CH3? You put a lone pair on it because it has to have a lone pair or else it's not a minus. Seriously. If that was not a minus, it would be a carbene. This is not a carbene. Grab an H, make that into a CO2 minus. Reminder, I'm just going to use PR equals propyl. I don't even have to say that, seriously. You can just use PR in a test without announcing it. It's an acceptable short form. We're going to be doing propyl all day today. PR is attached to carbonyl with an O minus. And the other product is CH3 attached to the absolute best leaving group in the universe. Right there. Why is that the absolute best leaving group in the universe? It has nothing to do with acidity and pKa. No. There's a different reason why this is such a great leaving group. It is entropy driven. It leaves as a gas. And you're done. I told you you'd like this mechanism. You do an acid-base step, you do an SN2 step, you're done. Gotta like that. 4 arrows, 1 or 2 intermediate. Fischer esterification. It's multiple times doing the same thing. Let's try to make it as condensed as possible. Red first. Blue second. Whatever color is not red or blue would be third. You've got to activate your carbonyl because a methanol is not a good nucleophile. Activating carbonyl right now with red. Grab H. Sigma becomes lone pair. You're going to need that conjugate base. So let's go like this and then go like maybe like this. HO3SO minus. Eventually that's going to grab an H. I'll give you a hint. I'm scribbling this H off, drawing the H bond right there. I didn't change anything. The next step is the attack on the carbonyl that you just activated using the poor nucleophile called methanol. Poor nu. And that would be in blue because you You can't do that attack until you've activated your carbonyl. There's your attack. You're going to generate an oxonium ion on the oxygen. This oxygen here is going to be an oxonium, which you'll have to neutralize using a base. What base? The conjugate base that we just made. Thank you. And we need a purple or something. The O minus grabs this H, dumps a lone pair there, and you have what's going to look like. It's going to look like, got an O up here. All the original stuff in green, all the new stuff in black. Got a new H there. Got a new OCH3 here. It's beginning to look a lot like the ester. Yeah. And that needs to become this. And to do that, it has to lose what? It has to lose this H. Yes. Somebody said water. I love it. It has to lose this H and this OH. That's water. Hey, acid catalyzed dehydration of any kind of alcohol. It's got OHs on it, right? It's like an alcohol, right? It's always the same. You need the acid to protonate the leaving group. And you need the base to grab the H from on top. First step, protonate the leaving group. Well, protonate to make a leaving group. It's not a leaving group yet. It is now. Now you can make it leave. It's an elimination of water right now in baby blue. There you go. That's as condensed as you can get a Fischer esterification right there. Okay, save that. And that ends this activity. See you for activity 3 soon.